Welcome to Concepts in Chemistry. In this talk, we'll discuss how to determine percentage abundance from isotopic and atomic masses. To start, let's read the following question. Silver has two stable isotopes, silver 107 and silver 109. Silver 107 has a mass of 106.90509 AMU, and silver 109 has a mass of 108.9047 AMU. Calculate the percentage abundance of each isotope. So here, based on the question, we only have the isotopic masses, but we need to calculate the percentage abundance of each isotope. So to make sense of this, let's look at the general formula we use to calculate the atomic mass of an element. So this is the formula used to calculate the atomic mass of an element. So as you read, atomic mass is equal to the fractional abundance of isotope 1 multiplied by mass of isotope 2 plus fractional abundance of isotope 2 multiplied by mass of isotope 2. So basically, we know the masses of isotope 1 and isotope 2, but we don't know the fractional abundance of each of them. And also, we don't know the atomic mass of silver. But there's a catch. Once you have the periodic table, you basically have the atomic mass of silver. So you locate your periodic table, look for silver, and read the atomic mass of silver. So that gives us the atomic mass of silver. So in addition to the isotopic masses, we also know the atomic mass of silver from the periodic table. So the only thing we need to find is fractional abundance. Fractional abundance, we can't find it from anywhere. We have to solve this problem before we can find it. So what else do we need to know to help us find fractional abundance? We have to recall that percentage abundance always adds up to 100% because percentage abundance is expressed in a percent. So that means that since to get fractional abundance, you have to divide percentage abundance by 100. Then it means that fractional abundance also add up to 1. Okay, so percentage abundance usually add up to what? 100%. But because we normally divide percentage abundance by 100 to get fractional abundance, then it follows that fractional abundance will also add up to what? To 1. Okay, so once we know that, once we understand this, then we'll say let X represent the fractional abundance of one of the isotopes, and then we'll then say 1 minus X should also represent the fractional abundance of the other isotope. So once we do that, we'll be able to solve for X, and then once we find X will now be the fractional abundance of one of the isotopes, and then 1 minus X will be the fractional abundance of the other isotope. Okay, so that is the trick to solving this problem. So let's look at how it's set up. Okay, so the atomic mass of silver, we look it up from the periodic table. Okay, and when I looked it up, it is 107.8682 AMU. And the mass of isotope 1, which is given in the question, so this is it. But now we don't know the fractional abundance, so we say the fractional abundance of isotope 1 is represented as X. So we now multiply the mass of isotope 1 by the fractional abundance X. Then we now add the result to the mass of isotope 2 times the fractional abundance of isotope 2. And how do we do that? Since the fractional abundance of isotope 1 is X, that means that the fractional abundance of isotope 2 is going to be 1 minus X, because the fractional abundance of the two isotopes will add up to what? 1. Okay, so once you understand that, then this is an equation that we can easily solve to find X. Okay, so once we find X will be the fractional abundance of isotope 1, and then we now subtract the X from 1, and we'll get a fractional abundance of what? Isotope 2. And to get percentage abundance, we just multiply the fraction of each of the fractional abundance values by 100 to get percentage abundance. So that is how to solve such a problem. So it's not really difficult if you really know what you are looking for. So again, atomic mass of silver from the periodic table, fractional abundance add up to what? 1. So you let X represent one of the fractional abundance values for one of the isotopes, and then 1 minus X represent the other fractional abundance. And then you then proceed to set up a linear equation like this, and then you then solve for X. And once you find X, you multiply X by 100 to get percentage abundance of isotope 1, and then you subtract X from 1 to get fractional abundance of isotope 2, then you multiply it by 100 to get a percentage abundance of isotope 2. Okay, or if you get the percentage abundance of isotope 1, you just subtract it from 100, and then you get the percentage abundance for isotope 2. Okay. So let's proceed to solve this problem. Okay, so I've rewritten the equation setup like this. So as you've seen, I've just taken the AMU out so that we just deal with only X. Okay, so we have 107.8682 equal to 106.90509X plus 108.90476, then in parentheses 1 minus X. So here we have to multiply the 108.90476 by 1 minus X. So that means that we have to expand it, okay? And then we bring like terms together, and then we solve for X, okay? So again, the X here represents the fractional abundance for isotope 1, and then the 1 minus X represents the fractional abundance for isotope 2. So let's proceed. So we do 107.8682 equal to 106.90509 X, then plus we'll do 108.90476, then minus 108.90476 X. Okay. So we bring like terms together. So we bring the x's together and also the numbers without x's together. So since 107.8682 it's on the left hand side and 108.9047 is on the right, I bring it across the equal sign. But it's plus over here. So when it goes across the equal sign, it becomes what? Minus. Okay. So just applying some algebra rules here. So we have 107.8682 minus 108.90476 equal to 106.90509 X, then minus 108.90476 X. Okay. So when we subtract this, we are going to get 1.03656, and it's going to be negative because 108 it's bigger than 107, so negative. And this equal to, here also is going to be negative, minus 1.99967 X. Okay. So now we want to solve for X. So we divide here by minus 1.99967. And then we do the same to the left. So minus 1.99967. So negative will cancel negative and the number will cancel that. Okay. And then here, when we solve, the negative will cancel negative. So when we solve, we are going to get 0.5183 and so on. Okay, so this will be equal to X. So this means implies, I'll just erase this. Let me just erase this now. Okay, so that's X. So our X is equal to 0.5183. So let's round it up to 2 decimal places. So we'll say X is equal to, since 8 is 5, so for 5, we just say 0.52. Yeah, 52. So this is our fractional abundance for isotope 1. Okay. So to get a percentage abundance, we just multiply that. So this is fractional abundance. So I'll just say fractional abundance. So to get percentage abundance, we just multiply 0.52 by 100%. And when we do that, we're going to get 52%. Okay, so the percentage abundance for isotope 1 is 52%. So what then is the percentage abundance for isotope 2? So we just subtract. Since now we've converted the fractional abundance to percentage abundance, so we just subtract it from what? 52% from 100. So we say, let me add another page here. So we say percentage abundance for isotope 2 would just be 100 minus 52%, and this is going to give us 48%. Okay, so 100% minus 50 plus 48%. So you see, so that is that. So our percentage abundance for isotope 2 is 48%, and our percentage abundance for isotope 1 is 52%. Okay. Yeah. So you could also do it the other way. So remember, we've found the fractional abundance for isotope 1 to be 0.52 after rounding. So we can just subtract that to get a fractional abundance. So this was fractional abundance for isotope 1. So to get for isotope 2, we'll do 1 minus 0.52, and this will give us 0.48. So this is fractional abundance for isotope 2. So we now, to get percentage abundance, we now multiply each by 100. So to get percentage abundance for isotope 2, we just say 0.52 times 100%, and this will be 52%. And then here we just do 0.48 times 100%, and this gives us 48%. So yeah, so whichever way you feel comfortable doing. So that is how to solve for percentage abundance. Okay, so let's go back to the setup. So you set it up like this, and then you apply algebra to solve for x. So you expand, because here it's in parentheses 1 minus x. So you expand the parentheses by multiplying through with 108.90476. Okay. So that is that.